Guys, I am just go on speaking and showing you the experimental setup, but automatically it got disconnected. Even I don't know about that. No one has not even said a single thing about it. But okay. Are you able to see my presentation? I almost completed the experiment, man. I did not know I did not connect in a Google Meet through my iPad. Okay, fine. Let me explain it once again. So in the gyroscope, you will be determining the gyroscopic couple in two different ways. The one is in the using an experiment, and the other one is using the formula that you can call as a theoretical way. So these two values you will compare at the last. So this is our primary aim of conducting this experiment. So gyroscopic couple is determined both by experiment as well as the theoretical, and then we will compare it. And how to do it, we shall just look into the experimental setup like this now. So this gyroscopic couple experiment has this particular setup like this. Okay. So it will be having a dimmerstat where it is used to provide the required amount of current into the motor, thereby you can vary the speed. Okay, so as soon as you turn the dimmerstat, you can observe the flywheel starts to rotate. Okay, so slowly you have to provide and increase the speed up to 2500 rpm. Increasing the speed from 0 rpm to 2500 rpm has to be takes place with a time span of 10 to 15 minutes. That means you can imagine how slowly you have to increase the speed. Why? Because you should not just go on increasing the speed at a single stretch, because it creates imbalance within the system. It may damage the system. That is the reason you have to increase the things very, very slowly. Okay, you can take 10 to 15 minutes or to increase from 0 RPM to 2500 RPM. As you can see, using the dimmerstat, you can just increase the reading so that more amount of current flows into the motor and it starts rotating. And the reading, the red color digital reading which you are able to see, that is the speed of the flywheel. Okay, that is the speed of the flywheel. So that is your reference through which you are going to increase it slowly and slowly. If you observe, now it is around 9800 something, okay, 1000 rpm. So it has to be reached up to how much? 2500 rpm. Once it has reached 2500 rpm, you have to see, now it has reached 2500 rpm, correct? So once it has reached 2500 rpm, you have to use this masses like this. This masses you have to use. So this masses has to be placed on the stand which is provided. The one is weighing around 970 grams and other will be weighing around 1.5 kg nearly. So one after the other. So one after the other, you have to just place it on the slot provided. So this is the slot you can see. There is a tiny rod there. So that as a reference, you have to place that mass onto this platform. So while it is running at how much? 2500 RPM. So once you have placed the mass, what happens? It starts rotating like this. It starts rotating. So for 30 degrees, for 60 degrees, and for the 80 degrees, how much time it has taken to traverse 30 degree, 60 degree, and 90 degree for individual mass. Say you have placed 500 grams of mass onto the pan. Okay, 500 mass onto the pan. Next, what you have to do? You have to, for 30 degrees rotation, how much time it has taken, you have to note it down. For 60 degrees rotation, how much time it has taken, you have to note it down. Similarly, for the 90-degree rotation, how much time it has taken, you have to note it down. So once you have noted down, what you have to do, you have to remove the mass. You have to remove the mass and add the other mass into the systems. Like this, you can observe the time taken using a stopwatch. Okay, using a stopwatch, you can observe the things. Similarly, you have to carry the same experiment for the 1.5 kg mass also. So once the 2500 speed is reached, hold a stopwatch in one hand and place the mass like this. And you have to place the mass like this. So once you place the mass, the whole system starts to rotate because of the gyroscopic effect, and you have to note down the time taken for 30 degree, 60 degree, as well as for 90 degree using a stopwatch. So this is the reading what you will take from the experimental setup. Hope that is clear for you. Now we shall look into the calculations now. So calculations, these are the readings which we get from the experimental setup. Okay, in the setup what happens? For first mass, that is 0.97 kg, for 30 degrees rotation, 7 seconds is the time taken. For 60 degrees rotation, 16 seconds is the time taken. For 90 degree rotation, 25 seconds is the time taken. And similarly, it goes for the other reading also. So you have taken the speed to be 2500. Length of the pan is 150 mm, which will be given in the form of the observation to you. Diameter of the disc is 300. Weight of the disc is 5.7. All these are required for the calculation part. Now we shall see the calculation part for this. I is the moment of inertia of the disc, which is given as WD into R square by 2. You know the value of WD and R. Just substitute, that is weight of the disc. Just substitute, you'll get the value of moment of inertia of that particular flywheel or a disc. Now, angular velocity is nothing but 2 pi n by 60. N you have known, you have set it to 2500 rpm. So you'll get the angular velocity as 261.79 rats per second. So now we have to calculate the angular velocity of precision. So this is very important. Angular velocity of precision. How will we be calculating? It is change in the angle divided by change in its time taken. So this is how we will calculate from the experimental point of view. It is d theta by dt. So d theta 1, d theta 2, d theta 3 just convert into form of radians. How will we convert? You have to multiply it by pi by 180, whatever the angle. So first you have taken for 30, next you have taken for 60, next you have taken for 90. So convert all these readings into the radians, which is 10.52, 1.047 and 1.57 in terms of radiation. So that is your dt value. And you have known the time taken for 30 degrees rotation, time taken for 60 degrees, time taken for 90 degrees. Correspondingly, you divide angle rotated divided by time taken, angle rotated divided by time taken, angle rotated divided by time taken. You will get the angular velocity of precision for the three readings like this. So once you got the angular precision, you can calculate the gyroscopic torque of rotation, that is I, omega and omega p. You have calculated the value of I, you have calculated the value of omega and even the velocity of precision. So just multiply it, you'll get the theoretical time period 1. And similarly for the theoretical time period for 2, second reading and the third reading. Now, the gyroscopic couple actual, you can calculate it as W into L, where L, W is what? The weight of the disc, and L is the length of the platform. So just you have to multiply, you'll get the gyroscopic couple. So there ends your experiment. So this is very simple experiment where you will have to calculate the gyroscopic couple for the experimental setup, whichever is given. So only these two masses will be given to you, no other masses will be given to you. So pretty much you'll get the same readings all the time. Okay, any doubts in this experimental setup? Any doubts, guys? Any doubts? Okay, understood. It's a simple experiment, man. Just you have to place the mass and note down the rotated this thing, degree time taken. For 30 degree, how much the time it has taken, you have to note it down. That's it. Before that, make make sure that it is at 2500 rpm. So only these things you have to remember. Maintain 2500 rpm. Place a mass. It starts rotating. For 30 degree, how much time it has taken? For 60 degree, how much time it has taken? And for 90 degree, How much time it has taken, you have to note it down. That's it. Any doubts? Any doubts, guys? Understood? Understood the experiment? Okay, pa. Fine, 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 fine. So we shall end up the session now. Okay. We shall meet up in the next week again. Take care, guys. Have a nice week ahead.